Today, inshallah, we're going to continue on the networking basics. We started talking last time about hubs. We talked about hubs and switches and did some simulations on the packet tracer software. I'm not sure if you downloaded the software or not, but today we're going to continue a little bit more and do some more simulations and also do some of the things that we did on packet tracer on the computer, basically, okay? So we're done with the switches, and basically what we said last time is about hubs is that the hubs work at layer 1. So basically they have no idea what the addresses of the clients or basically the network computers are. Basically the hub itself doesn't know the addresses, so basically it doesn't forward from one sender to one recipient. Basically whatever is sent is taken by the hub and basically repeated on all the channels. So basically whatever is sent, basically sent to everybody. And whatever is basically sent to everybody, basically you can basically just repeat it and send it. And basically this is one of the problems that we saw in hubs, because basically it increases network traffic and also it is a security risk. Switches are a little bit more intelligent because basically they work on layer 2. So they work on what's called the data link layer. The data link layer knows something called MAC address. MAC address is what's called media access control. Basically, this is a unique address for the network access control device. Basically, if you have a network card, for example, it will have a MAC address that is unique to this card. So if you buy 1,000 network cards of the same brand, of the same model, of the same everything, each one of them will have a different MAC address. So basically, switches know which one of the network access cards connected to here, one or to port 1 and port 2, port 3, port 4, and so on. And the messages are forwarded based on the MAC address. So basically, if a particular device wants to send a message to the device at port 8, basically based on its MAC address, basically the message goes from 1 to 8, and that's it. It doesn't go anywhere else. Okay, so basically this is much better in terms of the network performance. It doesn't have as much traffic as what you have with hubs. And at the same time, it's much more secure than the hubs, because basically the message is basically goes from one sender to one receiver, doesn't go anywhere else. One very important extension of switch is basically, just imagine that you have at the Faculty of Engineering, you have 4 floors, and each floor has a lot of computers, basically in professors' offices, and basically you need to connect all of them to one network. Okay, so this happens by switches. Basically, you have a switch every floor, or basically if you have a department, a certain department or a certain set of offices, you have a switch that connects all the computers in this particular group. Okay, and you have each one of the floors will have a switch like this. And then you connect the switches. You take one of the entries here, one of the ports here, and you connect it to a core switch. So basically, this is a switch that connects to all the switches. Okay, and basically the switch here can go basically to connect to servers or whatever, but actually you can connect all of these together, first of all, and to a server based on switches. So basically the idea of having the server as a central component like this and all the computers attached to it like this, it's basically just a representation, doesn't have anything to do with reality. Basically, the servers are here. They are connected just like these computers. They are connected to switches, and all the switches are connected together. If you have a configuration like that, then from each one of these computers, you can access these servers without any problem. So basically, this server can be connected to all of these computers if this network is configured properly. Okay. One thing that we can do actually with this particular configuration is that we can do something called network division. We can divide different groups of computers into a subnet, or basically a certain work group that is different from the others, or that is a little bit separate from the others. Imagine that you're working in a company, or basically let's just consider a hospital, okay? You have computers for the physicians, you have computers for PACS, you have computers for finance, you have computers for administrators, you have computers for security, okay? So basically you have different departments and they are all connected to the hospital network. It's not a good idea to have all these computers connected together. They should not be basically visible from any one of the computers. So for example, if someone is working from the physician office, for example, can he access the finance computers? He shouldn't be able to do that. Can he access the security computers? He shouldn't be able to do that either. Okay, so basically you should be able to segment, or basically have certain departments or certain groups of computers connected together in like a subnet or a network that is basically each one of these computers see the other computers in the same subnet, but they don't see the other computers in the other subnets. Okay, so this is actually much better from the point of view of security and privacy, a lot of things actually. How can we do that? Okay, we're going to see how to do that by a very simple trick actually that's called a subnet mask. One of the things that we saw last time, one of the parameters that we read in the basically in the ipconfig command, basically one of the outputs was the subnet mask. Okay, we can actually configure the subnet mask so that we can actually divide the network into separate networks that they don't see each other. They cannot communicate with each other. Okay, let's try to do that now and see how we can do it on packet trace. We'll go basically now. I'm going to close this screen now and basically share the desktop so that you can look at the whatever I have on packet trace. Okay, so basically I have the entire screen share, and I'm going to go to packet tracer, just make sure that it appears. Okay, you should be able to see packet tracer now. As you see from last time, this is exactly the network that we had last time. We had two PCs and we had a laptop and connected them through our router. Okay. What we did last time, basically, let's see what we have here. In the configuration, we decided to have, let me probably get it from here. In the configuration, we decided to have it at DHCP, which basically I'm going to talk about later this lecture. This is one of the services that we're going to talk about. This is basically a service that allows the router to automatically assign an address to each device. So basically, this is like an automatic. So static means that I'm going to have to enter everything. Dynamic, or basically it's like the router will actually do that for me. Okay, so basically it will fill out these parameters. One of them is the subnet mask. Okay, if I wanted to change the subnet mask, I actually have to do that statically here. So basically, if I wanted, let's try first to have the ping command, just to make sure that it's working. Basically, the addresses for these computers, this was, I think, 101. Maybe you can see it here. We can just ipconfig here. So basically, the address here is 192.168.0.101. Okay, and the subnet mask is 255.255.255.0. Okay. Okay. So the other computer here, I think it's 102, and the laptop was 100. So let's ping. Ping basically sends a packet of information between this computer or from this computer to a particular address. And basically, if there is a computer on the other address, basically it would respond. Okay, so basically these computers should respond. So 192.168.0.102. So this seems to be working. Basically, there is a reply coming. Basically, this is done 4 times, and I got a reply each time. Okay, let's try 100. I think the laptop was 100. The address for the laptop was 100. It's also working. Why do these computers see each other? Let's try something and see if it works or not. Okay, I'm gonna go here to the config. I'm just gonna close this and go to the configuration and make it static here. Okay, I'm going to enter another address, 192.168.1.101. So basically, instead of 0, I put 1 here. Okay, and we see subnet mask is still there. The default gateway, I can put it the same as before. Basically doesn't matter, but actually the address now is 101. Let's see what's gonna happen if I do that. Go to the command here. I'm going to try the IP config again. So here now, the address is 192.168.1.101. So basically, this is just the difference. Instead of 0 here, I have 1 now. Let's try the ping command again. So basically, it's working. So basically, it is connected to here. As you see here, the link is working. Basically, as long as you have green here, this means that they are connected. Okay. But now, if I try the ping command again with the laptop or the whatever, let's try the laptop. Now it doesn't see it. Basically, it's unable to communicate with it. Why is that? Basically, this is a problem from the subnet mask. Okay, let's go back here to the lecture and basically explain it a little bit more before we do some more experiments. So I'm going to close that again and show it to you in the lecture. You see the lecture now? Okay. So now the subnet mask, what does it mean, the subnet mask? It's written as 255, 255, 255, 0. The subnet mask, basically, if I wanted to communicate, if I want to communicate between computer A and computer B, the IP address here is whatever, okay, for example, 192.168.1.101. This is exactly the computer that I tried to use, basically. And the other one here was 192.168.0.100. And try to get basically they are connected, they are all connected to the router, but basically I was unable to basically communicate from A to B. Why is that? Basically the subnet mask here, just imagine this as a binary number. 255 means 8 ones, okay? And this is also 8 ones. And this is also 8 ones. And this is 8 zeros, okay? The subnet mask means that basically I care about these particular characters or these particular addresses or address numbers, and I don't care about this one here. So basically, if I wanted to communicate between these two computers, what I do is I AND this subnet mask with this, and I AND it with the same address, I AND it also with that. Okay, what is the result here? Basically, all these are ones. This is whatever. This is basically, if I AND anything with ones, it should be exactly the same. So it would come out like 192. Here, 168, basically exactly the same. 255, it's gonna come out like 168 because this is, I'm ANDing certain numbers here, ones and zeros, with all ones. So basically, they will come out exactly like this. For this one here, because this is 1 and this is 255, also is going to come out like 1. This is 101 ANDed with 0, it's going to come out like 0 all the time. okay? Here, if I do the same thing, it's gonna be 192.168. Here, because I have 0 ended with ones, then it's gonna come out like 0. And this is 100 ended with zeros, then it's gonna come out like this. In order for the computer network to know that these two computers belong to the same subnet, these have to be exactly the same. Are these the same? Are these the same? They're not the same. Then you cannot connect. You cannot connect. Okay? So basically, let's think about a way to make this work. How can I make it work? If I wanted to keep this one here, and I wanted these two networks to basically communicate with each other, what should I do? Basically, this subnet mask can be changed. Okay, so basically, I can basically replace this. If I replace this with 0, for example, what's going to happen here? This would be 0. And if this is 0 here also, basically this would come out like 0. So basically, this would be exactly the same. But do I have to make it all zeros? No, I don't have to do that. All I have to do, basically, if I wanted to make the first bit, only the first bit, because basically this here is zeros and only one in the least significant bit. So basically, if I made this like 254, 254 is 255, but the least significant bit is 0. Okay, so if I make this 254 here, 254, it should work also. Let's try that. So I'm going to go back and basically change that to desktop and try it there. Okay. So what I'm going to do now is I'm going to go to the configuration here, ipconfig, and make this as, let's try it first as 0. See what happens. So basically now it's 0. Okay. So let's check if it's working or not. If it's the new setting took effect or not. So I'm just going to try ipconfig/all. Here, the subnet mask, as you see here, it became a little bit different. Let's try to communicate now with the other computers. Try the ping again. It doesn't work. Why is that? Can any of you tell me why is that? It still doesn't work. The other computer still has the same subnet mask. So basically, in order for the computer to recognize that they are on the same network, all of them should have the same subnet mask. Otherwise, I might think that I belong to you, to your group, and basically you say, no, you don't belong to my group. So basically, you don't accept whatever I communicate with you. So what I'm going to do now is I'm going to go here, and I'm going to go to the desktop here in the configuration. I'm going to change that. Basically, I'm just going to make that the same thing. 0.100, same address, but here I'm going to change that to 0 and 0. Basically, I change that now so that the subnet mask now is exactly the same as the one that I used to have there. So basically, it's now present in both of them. So let's go to the PC0 again. And let's try it first from laptop 0, just make sure that it's configured properly. The configuration took effect. Okay. Now it's working here. As you see here, it should be working. So I'm going to go to PC0 now and try again the same command. See, now it's working. Because both of them, basically, because of the subnet mask, they know that they belong to the same group. Okay? So basically, this is okay. Okay? So basically now they know each other, they know that they belong to the same group, so that basically you don't have any problem, okay? Can you see that? What I'm going to do now, I'm going to change the subnet mask. Instead of having 0, I'm going to have 254, okay? If you have any question, please ask anytime, okay? So instead of 0 here, I'm going to have 254. 254 is all ones, 7 ones, and 1 0 at the least significant bit. Basically, I have the difference here in the least significant bit, because basically the address here is 7 zeros plus 1 in the least significant bit. So base 254, if I AND this with this, it's going to come out like 0. So basically, I'm going to change it like this here and make sure that it's working. I'm going to do the same thing here also, just to make sure that it's working. Okay, before we do that, maybe I can still run the, from BC0, I'm going to still run the ipconfig. Now it's different, 254. Let's try to run the ping again. It's actually working, because basically if I do the AND here that we talked about, the AND here will come out exactly the same, because basically I ANDed here 254 with 1, and basically I ANDed all ones and 0 in the least significant bit with all zeros and 1 in the least significant bit. So basically it's going to come out like 0 here. So it's going to be exactly the same as this one here should work. But I mean, you really, you don't want to have a subnet mask that is basically just zeros here. Basically, what you need to have here in the subnet mask, for example, if I wanted to have, for example, 10 computers, okay? So basically, I want to have a subnet mask that would be suitable for 10 computers, okay? So what I should do is probably have 255.255.255. This number I should think about. 10 computers, this would fit in 16 bits, 16, less than 16, because I need to have, if I consider like 1, 1, 1, 1, 1, 1, 1, 1, basically, I can fit my 10 computers within 4 digits, within 4 bits here. So basically, I can have here, basically 1, 1, 1, 1, 0, 0, 0, 0. Basically, the part of the address that I can change, or I should make the part of the address that can basically be allowed to take different numbers, I should make it zeros, and the other ones should be made like 1, so that they are constant. Okay, so basically here, this is like 128, 64, and this is 32 and 16. Just add these. I'm not sure. This is actually gonna be, I think, like 15. So 255 minus 15. So basically, it's gonna be like 240. Okay. So basically, if I use a mask like this, this would allow me to have up to from 0, 0, 0, 0 to 1, 1, 1, 1. So basically, it's a total of 16 PCs or 16 addresses within that subnet mask. Okay. If I wanted to have, for example, 50 is less than 64, basically. So basically, I can make it like, instead of having only 4 digits or 3 bits here, I can make it up to here, for example, okay, for up to this bit right there, okay? So basically, this bit right there, okay, yes, this bit right there. So basically, I should choose, yes.
العلاقة بين الاي بي والسب ماسك ضرب ولا ايش؟
Basically, it's AND. Bitwise AND.
Okay.
Okay, so bitwise AND it's very much like multiplication, but basically you're multiplying digital or basically binary numbers. So basically here you have 192. 192 is gonna be like I think it's 128 plus 64. So basically gonna be like 11000000. Okay, you're going to multiply it with 1111111. So basically multiply these 0, 0, 0, 0, 0, 0, 1, 1. So it's going to be exactly the same as this one here. ANDing is like multiplication, but it's you know, we're talking about digital, single digital or single binary digits, basically. But of course, if you're talking about the whole numbers, it's not definitely not multiplication. It's binary or bitwise ANDing. Okay, so basically, this is just an example of how you can create a subnet within your network. So you can assign certain computers a range of addresses and a subnet mask so that they can actually communicate with each other. You can communicate freely with each other, but the other computers in another subnet will not be able to do that. So this is very useful, actually. Okay. So this subnet mask actually is going to come. You're going to see it in the homework, and it's going to be one of the things that you're going to do in the project related to this part of the course. Such things are, you know, the kind of problems that you have to practice in order to understand. Sometimes you might not really see the point or see how it works right away, but actually, if you try and ask and basically make a mistake and then ask why is that wrong, basically. Then you understand it, and basically whenever you understand it, you'll never forget it. Okay? So this is very important. Any questions about this part? Okay, so let's go back. So basically, let's continue with the router. Is this clear to you? Still available? Is it still visible for you, the lecture?
Yes.
Okay.
Yes.
So now we're going to talk about the routers. Routers are a different device from switch, okay? So routers are a little bit higher. They work at layer 3. They work at the network layer, basically, okay? So layer 3 is actually where you have IP addresses, okay? The layer 2 was working with MAC addresses. They don't know the IP addresses, okay? So now you have a higher intelligent or more intelligent device in the network, okay? The router actually is extremely important because basically this is the device that basically makes the internet. So the internet is a connection of routers. That's it. So basically the internet that you hear about is just a collection of routers, okay? Your router at home is connected to a router at the internet service provider that is connected to routers in different servers around the world. And basically all it does, basically, whenever you want to access the internet, you basically go through your router, okay? And basically it sees exactly if you want to access a certain address, it makes that translation and basically finds the best route from your computer or from your router to this address, and basically goes through that route and basically gets the information and comes back to you. Okay, so the router is your connection to the global internet. Okay, so basically the router from one side, you can imagine this router as basically from one side you have wireless LAN, you have everything, you have a regular switch, okay, that works with your local area network. It connects all your devices at home. But at the same time, it has a connection to the internet, to the global internet. Okay, so basically here you have different devices that might be wired like this, might be wireless, but basically they are all connected through the router. Basically the router is acting like a switch in this case, but actually it's connected through the router to their global internet. The addresses here, the LAN addresses, are very different from the internet addresses. Let me show you what I mean, okay? What I'm going to do now is I'm going to open command prompt on my computer here, okay? And I'm going to try the ipconfig command. Is it clear enough for you? Do you see the numbers and everything?
Yes.
Somehow.
Okay. So now my address here, if you see it, is 10.18.34.94. This is my IP version 4 address here, okay? So basically, is this my internet address or not? Okay, let's find out. First of all, see here the subnet mask. Basically, the network is divided into 255 computers. So basically, it's maximum of 255 per group. So basically, the subnet mask looks like this. So basically, you can change any number here, and it will still not work. So basically, any number that is 10, 18, 34, any number here, 100, 200, 250, any number here below from 0 to 255, it would be considered as within the same subnet, by the way. Okay, so let's find out what is our internet address. Okay, how should I know? How can I know my internet address? The easiest way to do that is just open a Google, okay, and write what is my IP. Here, 195, 66, 128, 34. Basically, this is a very different IP address. The thing is, basically, if my computer is connected to a certain router at King Abdulaziz University, any other computer connected to the same router will get the same address. Let me put it another way. If you have a router at your home, all of you have a computer, have a network, have a internet at home, you have a router that you got from whatever the internet service provider that you have. Basically, any device at home basically will be connected to the internet through one address that is given to that router. Okay, so if you write what's my IP address in any one of the computers you have at home, you'll get the same address for all of them. Okay, so if there is another computer here at King Abdulaziz University that's connected to the same basically same router that I'm connected to, basically you get exactly the same address here. So basically, this is very important. The internet is a collection of routers connected together. That's it. It's not more than that. Okay. So basically, the router at King Abdulaziz University is connected to a router at the internet service provider that is connected to a router in a global internet service provider that's connected to a router in a certain server somewhere. So basically, you have all these routers connected together, and they share information about how to reach certain addresses, and that's it. Basically, this is the internet. Okay, so the internet is just basically the router you have at home is a part of the global internet. Okay, if you have a switch, if you have a hub, no, you have a local area network. You have a small network that is not globally connected to the other computers in the world. Okay, so this is very important. Okay, so routers are very different from switches because they are connected to the global internet. They actually make up the structure of the internet, basically. So basically, whenever a router receives an incoming packet, it reads the destination address, okay, and then using the information in its routing table, sends packets to the next network towards its destination. So basically, you have a router with its network, and another router with its network, another router with its network. So basically, if I got a request from this computer to this router, it would seek the other networks to know exactly which one is basically relevant, or basically would give it the least or the shortest route to the destination, basically. And it keeps hopping between routers until it reaches the destination at the end. Okay. So basically, imagine the same thing that we did a little bit, ago on the packet tracer. We sent a ping, through the router to another computer on the local area network. What about if I wanted to do that on a global server? Let's try that on Google, for example. I'm going to Bing Google, okay? Bing Google.com. Okay, it's not working. let's try something a little bit different. Let's try ping. What else? I think Blackboard doesn't work. Maybe maybe Kspace, my own. Okay, it seems like there's a problem here from the network at the university here. It doesn't allow ping. Okay, so basically, I actually used to give this course or a similar course from my home. Basically, last year we were not able to teach from the university. So basically, I was able to actually, you can very easy actually, if you try it now on your computer, if you connect it from outside the KAU, you can actually connect to, you can ping Google or ping Microsoft or whatever, their message. It's working, yes, basically, because you are outside, basically. The King Abdulaziz University is a little bit secure, too much security probably. So basically, it doesn't allow ping. Basically, it doesn't allow incoming or outgoing ping. Okay, but actually, if you're working from your own internet from at home, for example, you should be able to ping any one of the global addresses. So basically, whenever you're doing that, how are you going to do that? How can you do that basically? How do you know that this particular packet should actually go through the global internet, not go through the local internet? So basically, if you go back to Packet Tracer here and open the addresses we have, one of the things that we saw here in the characteristics of from the IP config, there is something called default gateway. Okay, default gateway. Actually, it's not defined here because this is not one of the things that basically we define. Basically, we don't have a connection here, so basically we didn't define that here. But if we go to ipconfig here, where? Yes, right there. There is a default gateway here, 10, 18, 34, 1. Basically, it's the same address as mine, but actually at the first number here, you have 1. Usually this is the case. Okay, if you have a router and you have certain sequence of addresses, usually you replace the least significant number here with 1, and this usually is the default gateway. So whenever you're trying to connect to a certain address, first of all, the router will check if this address is available in the local area network. If it's not available in the local area network, it would take it and basically consider it as sent to the global internet. So it uses this gateway basically. It sends the information to the default gateway here. Whatever is sent here will be sent to the global internet. Okay? So basically, this is one of the important addresses. And basically, if you trying to access your router, basically, it's going to be the address of the router will be exactly like this, basically. Okay, so if you have at your home, for example, if you have 192.168.1. whatever, okay, .1.100, for example, this is the address of the computer. If you try 192.168.1.1, it will basically open the page for your router, basically the administrative control or the graphical user interface of the router. Okay, so basically this is something that you can do actually. Let's try this here, by the way. Maybe we can try it here. I think we can try it here. I think unfortunately we don't have an address here, but actually we can configure it. Basically, usually when you open a router, you will get something that looks like this, basically, and you have a certain IP address for it here, like this. Okay. I think in order for us to get, okay, I think what I should do is get from here. I think if we go to desktop and configure here, okay. If I do the DHCP, then this default gateway will be filled automatically by the router, so it's there. What I can do now is I can probably just try a web browser. And what I'm going to try to do is put the address of the gateway and see what I'm going to get. Okay, it's actually it has authorization. This is basically is trying to open the configuration for the, let's try admin. I'm not sure if this will work or not, but let's try it. Okay, it worked. Okay, so basically, as you see here, I'm accessing the same exact configuration of this router from PC1, because basically I just put the address here, the address of the gateway, and put the credentials admin. Okay, if you have your own router at home, usually it has a default password that you can find at the bottom of the router. Basically, if you read the information on the router, it will have the admin and the default password that it comes with. Usually, whenever you get a new router, you should actually log in once and change this password so that it's not available for anybody to. You remember what we talked about in the cybersecurity part of this course? We said that there are some routers that come with a default password that is well known, basically. So if somebody is able to, for example, gain access to this router and basically try to log in with this default information, he should be able to do that. And if he does, basically, he can compromise your network. Okay, so basically, now I entered the admin, and I was in from another computer, basically. And whenever you do that, you can change a lot of things here. You can change the subnet mask, you can change, see here, you can actually change whatever you want, see. Basically, 0 here means you have 256, so 256 devices that can connect. Here 128. Here you go a little bit less until at the end you can get if you have 240, you have 16, and so on and so forth. Okay, and you can actually increase. You can actually increase the number basically if you actually change this number here. But basically you can just keep it the same. And basically here you can actually select if you want to have the DHCP server. We're going to talk about this a little bit later in the course, the meaning of the DHCP. But this means that your addresses will be allocated or assigned automatically or dynamically. You don't have to put the addresses yourself for each device. This is definitely much better than static addresses, because basically for static addresses, there is a chance when you're entering the static address, you have no idea if this address was taken before or not, unless you have a very strict policy on basically recording any addresses that are taken, okay? And you're following this policy, or everybody in the organization is following this policy, it's gonna be a problem, because basically it's very likely for a new device or a new guy to enter the incorrect IP address and make what's called IP conflict in your network. IP conflict will have a variety of symptoms, but it's definitely going to be a problem for these two devices. Okay, so basically, DHCP is a good thing. Okay, it's available as a service from the router. If you don't want to use it, you can actually change the address in your device and make it static if you want to, but actually the service is available. You can also here decide when exactly you're going to start the IP addresses. So here they started from 100. If I change this, I can change it to, for example, 50, or change it to 10. It's up to me, actually. I can change the starting IP address, and basically I can also set the maximum number of users. So if this is used as a wireless access point, for example, sometimes you have too many users, and basically the service will go really down if you have too many users. So here you can control the number of people who can connect to your router. Okay, so this is really good. One of the things that you can do also with the router, if you have a wireless router, basically in this part here, what you can do is, if you look at the security here, the security mode here is disabled. This is really bad. Okay, what you should do is to have at least WPA2 person. Okay, there are several of these actually, but all the older versions of WPA, the regular WPA or the WEP, were good at some point in time, but actually people found cracks in these security algorithms. Some of them actually have very limited number of keys, Basically, instead of having a wide variety of keys and a very long encryption and things of that sort, basically they have a finite set of keys that people can use to encrypt the communication. For wireless in particular, you have a big problem in that the information is in the air, basically. If somebody parks right by your company, he can actually get access to your wireless network, basically. He can see the traffic in your wireless network. So if you send the information unencrypted, then basically all he has to do is just basically listen and basically download whatever. You just listen and log the information that is sent through your wireless network. So whenever you're using something like this, basically you're encrypting your communication between the devices and the router. And so basically if somebody tries to listen, tries to eavesdrop, basically you won't be able to get the information that you're sending between your device and other devices through internet. So basically this is very important. So basically this is definitely better to have at least WPA2. Depends on personal or enterprise. There are differences between these two, but actually all you have to do here is just put a passphrase, whatever the passphrase you want, okay? And basically it should work, okay? So basically let's go back to the routers. Routers can also perform security function. They can be configured to filter out specific types of network traffic. This is actually, we can see here in the router interface here, you can have access restriction, you can have security here, you can have different firewall protection. Basically, you can have SPI firewall. You can basically filter anonymous filter requests. You can put basically different kinds of filters here. And basically for the access restriction, you can actually decide that certain web pages are not allowed. You can decide that certain IP addresses basically cannot access, or basically decide the kind of traffic you'd accept coming in and the kind of traffic you would accept going out. And basically you can make certain rules and basically enhance your security based on that. Okay, so basically usually you have kind of access restriction. You can also have certain kinds of if you have many devices in the same place, and you know that some of the devices in the same place on that place don't belong to your network. For example, if you have 2 access points and one of them is dedicated to a certain group and another is dedicated to another group, so basically some of the addresses in the other group should not work with the other router, basically. So you can basically detect these addresses and basically filter them out, or basically prevent them from connecting. So basically you have here firewall, and you can actually basically have it enabled here. Actually it's you can actually, this doesn't seem to be working because the internet is not connected, but actually in the actual one, if you're working with an actual router, you should be able to do that. Okay, so basically you can actually use that to do some security functions that we talked about in the cybersecurity part. So it can be configured to filter out specific types of network traffic. So for example, as with King Abdulaziz University, they decided to basically block ping. Ping is one of the one type of network traffic, basically. They don't want to have people basically pinging on their server and basically putting a chance, or basically having a chance of some kind of like denial of service attack based on ping, for example. Okay, you don't want to have that. If you have a one ping, it should be fine. But if you have a billion ping from different computers, then it's going to be a problem. So basically, they decided to filter out such network traffic. The router also can be set to disallow incoming packets that have invalid addresses, or disallow packets from specific addresses. So you can actually filter out certain addresses in your network. You say that, for example, some companies actually filter out some kind of like streaming movies, for example, okay, because they don't want their employees watching movies in the middle of the day or at work. So basically, you can filter out some network traffic that is related to streaming media. okay? They can actually have certain addresses blocked, okay? They can basically disallow some packets that have malicious content. Sometimes actually the attack would include malicious content in regular packets. So basically we would try a regular service or a normal service, but they actually put some of the information as incorrect information or invalid. So sometimes if you try to process that, it would actually take a much longer from the computer to understand it. So it would end up being some kind of a denial of service attack. Okay, so basically you can basically through the router, you can actually prevent these packets from the server before it reaches the computer at the, at all. Basically from basically the entry point from the router, you can basically block them out. Okay. So basically routers are extremely important. As I told you before, this is basically the building block of the internet. Basically, this is basically whatever you're trying to do, or basically whatever the internet is made of is basically routers, and these routers talk together or talk to each other. And basically your traffic goes from one router to another until it reaches your computer, or basically reaches the destination and gets your information from there, and also hops through different routers until it comes to your computer at the end. Okay? Do you have any questions? Okay. I would like you to try the thing that I try here at the lecture, and basically this is the only way that you learn that. And these are really useful things, okay? Whenever you basically work in an environment where you actually need to interact with the network, this is really useful. Even at home, if you're trying to fix something at home, this is actually really useful, okay? One thing before I leave this part, actually, the difference between static address and dynamic address, sometimes if you have a resource within your network, like a printer, for example, like a network printer, like, for example, a network scanner, like, for example, whatever, okay? Like, for example, if you have a PAX system, if you have a digitizer, then it's actually usually connected as a network digitizer, for example, okay? So basically, it's better for such devices to have a fixed address. The problem is when you change the address, if you make it as DHCP, then it will basically, whenever you put it, whenever you start it or turn it on, basically it will get an address from the network, okay? Depending on when this happened, okay? So basically you configure all the other devices to know that this is available at this address, and basically you start communicating at this address. And if basically electricity goes out, or somebody switches off that device for service or whatever, and basically turn it back on after that, most of the time it would get a different address. And this would sometimes cause some problems in the network. So basically if it's a resource, it's a printer, something like that, then it's better to have a static address, okay? So basically this is one important thing that you should take care of. The other devices, the other computers, actually they are much better if they are basically allocated dynamically. Because sometimes if you're talking about wireless devices like mobile phones, for example, you're not there all the time, basically. You're there part of the time, and then some other people come later, and some more people come later, even later, and basically you want to use the same network for all of you. If you count the number of devices that connect to the network, basically they might be like 1,000. But at any given time, it's probably like 100 only connected there, okay? So basically, if you reserve an address to each one of the devices, basically then you need 1,000 address, which doesn't make sense. Okay, so for example, here at King Abdulaziz University, you just connect DHCP. Basically, you don't have a static address. You just, whenever you are within range from the wireless network, you get an address, and that's it. You work with that address. Whenever you leave, basically, this address is taken by another device, and that's it. Life goes on. Okay. Sometimes you use, in order for your network to be a little bit more secure, this is basically something also done here at King Abdulaziz University, is that whenever you try to log in You don't log in just locally on your computer. You log in globally through the KEU domain, okay? So basically, instead of having, if you have multiple computers, you have many computers actually like in a hospital, and each one of these computers is connected, or basically you can log in to these computers basically using certain accounts, university accounts. Then it's better to maintain all these accounts in a central location where you have all your policies, you have basically the access control, things of that sort. If you remember from the EHR part, we mentioned that you have to give different users different access levels, basically. If you want to do that from each device, it's going to be really difficult. If you want to go and configure each computer, okay, basically, if you have a user working on a certain computer, basically you go to this computer and configure it for that user, and then go to another computer to configure it for another user, and the third user, and fourth, and so on. This is extremely difficult. Okay, so people came up with something called domain controllers, and these domain controllers actually would basically be made of a collection of devices, and basically they share a common database that has all the account information and all the security information, including the access levels and all these kinds of things. If you want to change the access level of any user or even remove that user altogether, you can do that from the central database, so that if he tries to log in from his computer, he won't be able to do that. So basically, this is a much better way of controlling the security within an organization. And this makes sense because basically otherwise it's almost impossible to try to keep up with the number of computers and the number of users. It's extremely difficult. Some computers are used by multiple users. Some computers are used by single user. Some computers are placed in locations that are locked. And it's very difficult to configure one computer at a time. You want to configure the security policy for everyone at the same time. Okay, so here, for example, at King Abdulaziz University, we have a global policy, and basically we all have to follow. Whenever I log into my computer, the computer that I'm using right now to give the lecture, I have to log in through the domain, the central domain of KU. Okay, and the security policies of KU apply to me. Among them are really things that I'm not happy about, but actually they are done centrally, basically. Like, for example, we have a really annoying policy of locking the screen every 5 minutes. So basically, if you're trying to read a paper, okay, you're sitting in front of the PDF or Acrobat or something, or you're reading a PDF file, and if you just wait a little bit, if you're focused on whatever you're reading, and the page is a little bit longer than 5 minutes, then the screen would lock, and you have to enter the password again in order for you to be able to basically see the screen again. These kinds of things are configured centrally. They are not configured on my computer alone. Basically, it's a policy that is basically applied by the KU domain. And because I'm a part of this domain controller, basically I access the internet through this domain controller, it's applied to me. So basically, this is a very good way of applying security policies in such an organization like hospitals, where we have to have very strong or very strict security policies and very strict access control and very strict logging of activities. Basically, it's better to have a domain controller, and usually it's recommended basically that if you have organizations that have more than 10 client computers, not that many actually. So basically, it's a good idea that you actually use a domain controller with all the security and security policies in a central location. Any questions? I think I'll stop here because actually I'm not going to be able to finish this. Right now, the Maghrib prayer is at 6:30 almost, okay? So now we started to give the lecture at 6:45. At the same time, Aisha prayer is maybe a few minutes from now. So I'm not sure if we're going to continue to push back the starting time, but for now, for the next lecture at least, we're going to have the lecture at 6:45, so that I can give 15 minutes for people to pray Maghrib and come and attend the lecture. Basically, when we started at 6:45, there were only maybe 3 people there. So basically, I hope all of you can manage to come at 6:45 next time, inshallah. Any questions? I sent you the information about the midterm. If you have any questions, please feel free to let me know, okay? Any question before we close?
Professor, sorry. Can we have the answers for the homework before the exam, like for homework 1, 2, and 3, please?
You can actually access that from Blackboard. If you click on your grade center, basically, if you click on your grade, basically, you should be able to see the graded homework, and you'll see your answer and the correct answer. You haven't done that before?
No, I haven't. But
please let me know if you couldn't. Let me know, and I'll let you know. Okay, I'll let you know how to do that, inshallah. Basically the midterm, as I sent you by email, it will cover EHR, cybersecurity, and PACS. That's it. It's not going to cover the networking part. Okay.
And what about timing with Maghrib?
Yes, the timing. Thank you for letting me know, because actually I almost forgot about that. Basically, one of your colleagues actually mentioned that it's better to have the exam in a different time from the lecture, so that first of all, you have more time, and you don't have conflict with the prayer times, because actually our time is really in the middle between the Maghrib prayer and the Isha prayer. So if you don't mind, I can actually change the exam time to be the same day as we agreed about, but actually starting at 9:30, for example, instead of 6:30. Would that be okay with you? If you start at 9:30, then basically you're done with all. Basically, I made it 9:30 because I know that some of you actually have a course after this course. So 9:30 would allow you to take an hour and a half. Basically, you can basically take an hour and a half if you want to basically attempt the question of the exam. The exam should be actually it's made for only 1 hour, but actually some people like to take a little bit more time. So basically, it will allow you to have more time if you need to. But if you have it at 6:30, then you have a very limited time. Basically, you have to finish at 6:50 if you have, basically you have to pray first, and basically this would take at least 10 minutes at the beginning, and then you have to finish before 8 so that you can pray Isha before the next lecture. So basically, you will not get as much time. So if you agree, I'll be happy to do that.
Fine with me.
Would 9:30 be okay?
Fine with me. It's okay.
Okay, if you have an objection, just send me a message now. Just send a chat here. If you disagree, if you don't say anything, then it would mean that you agree. So that we all see if anybody disagrees about that. Okay, we have 8 people, and all of them agree. Okay, so inshallah we'll schedule the exam to be inshallah at starting at 9:30 inshallah. Okay. From now till then, if you have any questions, please send me a message or send me an email or whatever. I'll be happy to help you. Okay. Regarding the homework, regarding any part of the course, regarding if you're not sure what to bring with you or whatever, or basically what I think it's not an in-class exam. But if you're not sure about any part of the course, just let me know, okay? Okay, thank you, and see you inshallah next Tuesday, inshallah. Okay, 6:45, inshallah. Assalamu alaikum.